So this is going to be the final review. I'm going to get started on pre-midterm things just in order to recap everything that happened before the midterm, since you need to know things before the midterm in order to do things after the midterm. Also, 5 questions on the final will be from pre-midterm material. So the first thing we're going to do is an example from an IVP, which is going to be cos t of y dash is equal to sine t times y plus cos squared t. And this is going to be an IVP, initial value problem, and we're going to set y0 equal to 4. Now first things first, you need to get this into the general form, and the way you have to do that is isolate y dash and put all the y's to one side. So we got sine y and cos y dash. So we subtract sine y and divide everything by cos t to isolate the y dash. So once we do that, we get y dash is equal to, we are subtracting over here because we are putting all the y's to one side, sine t over cos, because we're dividing everything by cos y, plus, now we're equating, I keep messing up, is equal to cos divided by cos, which is just cos, because we're cos squared. So we have this equation now, and we define the coefficient function here as p of t and this function as g of t. So once we found our general form, we have to find the integrating factor, which is u of t, and u of t is equal to e to the integral of p of t. And it's easy to find the integral of p of t because we've already defined it in our general form. So it will be equal to e integral negative sine over cos t, don't forget the t's, and that will be equal to, so the integral of negative sine over cos is actually equal to ln of cos t, and the absolute value, of course, plus c, but we don't need that. So the ln and e cancel out, therefore the integrating factor is equal to the absolute value of cos t. Once you found your integrating factor, you multiply and solve. Therefore, we multiply our general form by u of t, and we will get cos t times y dash minus cos t times sine t over cos t. I'm just not simplifying right now, just to see everything how it is equal to cos squared of t, because we just multiply cos by cos t. I'm gonna erase and then add more room. So once we have solved for this, we once we've multiplied the general form by the integrating factor, we know that this portion before the equal sign is actually equal to the derivative of cos t times y with respect to t, and that would all be equal to cos squared t. Now in order to finish this differential equation, and that is find the integral of both sides, the only way we can do this is by knowing our trig identities, which is, in this scenario, there is a trig identity for cos squared t, and it is actually equal to 1 plus cos 2t all over 2. That is the trig identity for this equation, for this. And you're going to have to know that in order to finish this differential equation. So once we've substituted in our trig identity, we can find the integral of cos ty, and then we'll have to find the integral of our trig identity, and that will be equal to cos ty is equal to the integral of this, and you're just gonna have to know the integral of this. The integral will be t over 2 plus a fourth sine 2t plus c. And if you don't know how to find that integral, you'll probably have to know that for the exam. If you don't know how to do it, I'll probably recap it at the end, I don't know. But for now, you just have to know how to do it. Once you found that, you want to isolate y in order to find y, because that's what we're solving for in the first place. Divide everything by cos t. And we get, well, we can just put sine 2t in the numerator, and we got cos t in the denominator, plus c over cos t. And the constants in this scenario, we always, whenever we're adding constants, dividing constants, we always say, let's say 2c is equal to c. That's not true in this situation. Always keep whatever you're dividing by c or adding, not adding, just dividing or multiplying by c in these scenarios, because it will affect your final answer. Once you've found this, now that is your differential, you have solved your differential equation. However, this was an initial value problem, and we did have the initial condition of y0 is equal to 4. So we know that y is equal to 4 when all t's are 0. We got a 0 here, this is 0. We got sine 2t, which is 0 again. And then we got cos 0, which is 1. So we know that 4 is equal to c. We can put that in, and we've solved our entire initial value problem. So we can substitute c, in the entire equation as 4. So that will be the recap for first order differential equations. Going back to what we had in our last equation, just a quick recap on a certain thing that is usually asked in almost all of our exams. This was the previous example that I just showed. Y dash minus sine t over cos t y is equal to cos t. And we have pt over here. And we have gt or qt, doesn't really matter what you want to call it as long as you know what it is. So what they usually ask is the interval of where this differential equation exists, and the way you do that is you find where p of t and q of t are continuous, and you find the intersection of that, basically. So we know p of t is continuous on negative pi over 2, because that's where cos of t, that's where sine of t, my bad, is continuous. And then we have cos of t on this side, which is q of t, which is always continuous. So that's on negative infinity and infinity. So we clearly know where the entire function as a whole will be continuous. It'll just be continuous on. So we know that the differential equation is continuous on negative pi over 2. Alright, so I'm going to go over pre-midterm topics relatively quicker now, because I don't think we should focus mainly on these things just because you should probably already know it. If you don't, then this is probably relatively helpful. So I'm going to show a quick separable DE and quickly solve one of those, and then probably go over exact differentials, Bernoulli's equation, homogeneous equations, and I'm not sure what else, but let's just quickly go through these examples. 1 plus x squared y dash is equal to half y squared minus 1. So we have this equation. What we want to do is find y, because this is a differential equation. So what we can do in this scenario is separate and solve. So what we're going to want to do is substitute. It will be easier to look at it if we just put dy over dx instead of y dash, because it'll be just easier to look at. So if we put 1 plus x squared dy over dx is equal to half y squared minus 1. Now what we can do here is put y, all the y's, the dy's and y's on one side, and put the dx and x's on one side. So we'll be doing that by, I'm just going to solve it out quickly. It'll be y squared minus 1 dy is equal to 1 over 1 plus x squared dx. You'll know it's a separable equation once you see that you got x's on one side and y's on one side. You're going to notice the trend. And once you do this, you got a dy, you got a dx, you can integrate both sides and solve for y. Okay? It's really simple. It's not hard at all. It's pretty clear from here what you can do. Integrals, solve for y. That's all you have to do. So now we're going to move on to exact equations. Okay. Exact equations. Exact equations are probably one of the easiest kinds, especially if they are exact. So what exact equations are, basically they're in the form of m x y plus n x y dy, sorry, I forgot the dx in the m, is equal to 0. So m in this scenario is equal to df over dx, and n in this scenario is equal to df dy. We're taking each one with respect to x and one with respect to y. So first thing we want to do is find the derivative of m with respect to y, and if that is equal to dn with respect to x, the derivative, then this is an exact equation, and you can solve using the general method of solving exact equations. So I'm going to give a quick example. Anyways, so we have a quick example. Cos y cos x plus 2x e to the y dx plus sine x. Hope this is visible. Okay. Plus x squared ey minus 1 is equal to 0. So what we're trying to find, since we know that they've defined this as dx and this as, clearly forgot that, since this is defined as dx and this is defined as dy, we know that this could possibly be an exact equation. And since this has been defined as dx, we know that this entire side is m. We know that this entire side is n. If it was the other way around, if there was dx here, dy here, then it'd be the other way around. It's in order just cause. So we need to find if the derivative of m with respect to y, not with respect to x, with respect to y, is equal to the derivative of n with respect to x, not with respect to y. Okay, that's a pretty big mistake everyone makes. And if you find the derivative of dy, like dm with respect to y, we'll get cos x, y goes away, cos x plus 2x ey. Ey will stay the same too. And then on this side, if we take the derivative with respect to x, we'll get sine x, derivative will be cos x plus 2x, because we got the x here, and this would just be constant, so it would just be 2x ey, and this is minus 1. It may have looked like it was in the exponent, but it wasn't, and then that'll just go away too. So they are equivalent, so they do check out. So once we know that they check out, we have to find the integral. So we know that they are exact. That's done. Once we do that, we have to find the integral of mxy, which is equal to y cos x 2x ey. This is just like a procedure that you'll probably have to just memorize. You'll have to know how to do this. Don't ask why we find the integral of this. This is the process. Just know how to do it, okay? Once we find the integral of this, it's equal to y sine x plus x squared ey plus c, but we're gonna define it as something else because we don't want to say c. We're gonna say, let's say k of y. We're gonna define it as some kind of function because it's more important to us than just a constant. So once we found this equation, the integral of mx y with respect to dx, we're gonna find the derivative. But we're gonna find the derivative with respect to y. We found the integral with respect to x. We're going to find the derivative with respect to y now. The derivative will be equal to sine x plus x squared power y plus k dash of y, because it's a function now. We're finding a derivative. If it was a constant, it would have gone away. Now this, the derivative with respect to y of the integral of mxy, we equate this to n right here, and we solve for k dash of y. So once we do this, we will find k dash of y, because we know it's equal to -1 because these two equations are identical besides the last part. And then we are going to find the actual k of y, which is equal to -y plus c. That's because we're just taking the integral, right? And then once we've done that, because most of these questions, they require the differential equation to be in terms of c, like they say equate it to c. That's what most of the questions ask for. So once we know that k of y is equal to -y plus c, we can finish this by writing the general solution, which will be this equation right here. The reason we found the derivative with respect to y was to solve for k dash of y, which ends up giving us k of y. And this will be our solution. So we get our solution of y sine x plus x squared ey. Not sure if this is visible. Okay, now it is. Minus y plus c, or we could take it to the other side. Minus c plus c doesn't fucking matter. It's c. It's a constant. And that's how you solve for exact equations. So just know, once you find that they're exact, you find the integral of m, and once you find the integral of m, instead of c, you want to put it as a function so we can find the derivative with respect to y. Once we find that, we can equate that to n, and then we can solve for k dash of y, find the integral of k dash of y, and plug it back into our integral of m and solve for our general solution. That's how you do exact equations. Things get a little bit weird. So we have our equation that we just went through, m x y d x plus n x y dy is equal to 0, and if the dm with respect to dy is not equivalent to dn with respect to dx, what do we do then? Well, then we have to multiply the entire, both sides, by an integrating factor. So we have to multiply both sides by u of something. I'm just going to put nothing in the middle because we don't know what that something is. So how do we find that something, the integrating factor that we multiply by both sides? Well, there are different types of integrating factors, and you're going to have to find out which type of integrating factor. So we got u of, one sec, let's see if I'm in, okay. We gotta find, you can either have u of x, u of y, or u of x, y, which is beautiful, right? Now the way we find these, it's not exactly simple. Sorry, so I'm gonna bring out my red marker because it's not exactly the prettiest thing. Basically, you're gonna have to memorize certain formulas. So to find out, let's say the first one, which is u of x, if the integrating factor depends on x, how do we know that? And that is if the formula, which is dm over dy, which is, we have already solved for that hopefully, and dn dx all over n. So this minus this over this. If this equation ends up having an x in it, then you will find u of x. Okay? If, now we'll erase that. Now if we have dn over dx minus dm over dy over m, this has a y value in it, then we will take u of y. You have to memorize this formula and the formula before this. Type 3, which is the last type. For type 3, you're just fucked. I got nothing. You're just fucked. So just know those two formulas that I just showed you, and once you get those two formulas, you multiply them by these two, and then you will get your exact equation and then solve it just like I did before. So let's quickly go over Bernoulli's equation, which is basically stating what will you do if you get an equation that is not linear. For example, y dash plus y plus x y squared is equal to 0. So what we can do, get it into the general form, subtract this to the other side, so we'll get equal to negative, and then what? Because we have a y squared, so what do? We got the y and y dash, we've separated the y's, the linear y's at least, on one side. Now we got this y squared. What do? We have to turn this equation into a, we need to turn it into a linear differential equation in order to solve it. How do we do that? We use Bernoulli's equation, which states that this is a this is the to the second order differential equation. So n is equal to 2, and what we're going to do is we're going to make a substitution, a z substitution, and our z substitution is going to be z is equal to y1 minus n. N is 2, therefore y is equal to negative, y to the negative 1, because n is equal to 2. So now that we have a z substitution, we have, so we still do need to simplify this more. This is not in the general form yet. So our general form will be all of the y's on one side. So we have to put all the y's on one side. So 1 over y squared y dash plus y squared over, that would be y to the negative 1 is equal to negative x. So we got z, y, which is y to the negative 1, which we can substitute in here. That's easy. Plus z is equal to negative x. But what about this? We got 1 over y squared times y dash. How do we substitute that? We basically use the substitution of, so basically z dash would be equal to, we already know that z is equal to this, so we can find the integral, which would be y 1, and it would be dy over dt, since our entire equation is respect to t, not x. Now that we have that, we know that y dash in general is equal to dy over dt or dx, depending on the context. In this context, it's dt, and you'll know that in the question. Now that we have this, we can put z dash, and it is a linear differential equation now, because there are no squares. So what you can do is find the integrating factor, and integrating factor, which is equal to e to the power of pt. We know pt because this is pt, it's just 1. And then you would solve the entire thing as a first order differential equation. And in the end, we do know that z is equal to 1 over y times y divided by y. Y is actually equal to 1 over z. So in the end, once we find z of x, we just take 1 over z, and that will be our y. Simple. Okay, so we have the Wronskian test, which is for linear independence. So say you're given the, so solutions that y1 is equal to x negative 1, y2 is equal to x negative 8, y3 is equal to 3, and it's told that these are solutions of x squared y triple dash plus 12 x y double dash plus 18 y dash is equal to 0. The Wronskian test only works on homogeneous equations, which means that the equations equate to 0. Now to find whether, so the Wronskian test is basically a test for linear independence, which means we use a matrix, and we use the matrix y1, y2, y3, which are these values right here, and then we find the first derivative of each, and then we find the second derivative of each, and once we've found that, we find the determinant, and if the determinant is equal to 0, then that means this is not a fundamental set of the solution. It's not a fundamental set of solutions of this differential equation. So for this one, it's going to be x negative 1, x negative 8, 3. 3 is going to be 0. Negative x, negative 2, 2, x, negative 3, negative 8x, negative 9, and then 72, x, negative 10. You'd want to find the determinant along the two zeros, would be the easiest. So we know that the determinant is equal to 3, which would be a positive because this is positive, negative, positive. 3, negative, so we can x negative 2, negative 8, negative 9, 2x negative 3, 72x negative 10. Find the determinant, plus 0, 0, well, these are all zeros. The determinant would be equal to 3 times x, negative 2, times 72, x negative 10, just crossing them, minus negative 8, x negative 9, times 2x negative 3, and this equates to 168 x to the negative 12. If you were to bring these two together, you get 72x to the negative 10, and if you do this side, I assume you get something too. I'm not going to do it right now. And this is obviously not equal to 0. And because it's not equal to 0, we know that these three are a fundamental set of this differential equation. That's the Wronskian test. So one of the things that they usually ask is how to solve differential equations in the form of y plus b plus c is equal to 0. This probably looks familiar from formula a squared plus b, or a, my bad. This probably looks familiar from this form because they are nearly the same. And these are second order homogeneous equations with constant coefficients. There's a certain way to solve these questions, and basically you'll have to find the discriminant, which is in the quadratic formula. The quadratic formula is negative b plus or minus square root of b squared minus 4. The actual quadratic formula is minus 4ac, but in differential equations our a will always be 1, therefore we don't have to put it in our equation here, all over 2. So what we're actually focusing on is our discriminant in reality, or this whole thing actually, I guess. Yeah. So our discriminant is this part of the equation, and there are certain rules that you'll have to remember when it comes to these specific second order homogeneous equations with constant coefficients, and that is that b squared minus 4c, the discriminant, if it is greater than 0, then this differential equation has 2 distinct real roots. If b squared minus 4c is equal to 0, then that means that, let's write 2 real roots. If this is equal to 0, then that means that there is 1 repeated real root. So 1 repeated real root. And if don't take that as a negative, or I'll just do that. And if b squared minus 4c is less than 0, which will mean that you'll have, because there's a square root, that will mean that there will be an I. It means that there are 2 complex conjugate roots. Okay, so this is only if it equates to 0 constant coefficients and it's to the second order. It doesn't work for anything else. So I'll go through like 2 examples. Suppose we have y double dash minus 6y dash plus 9y is equal to 0. So what you want to do is we'll find the roots find the roots, which is r squared. We'll substitute r for y's, and we'll put r minus 6r plus 9 is equal to 0. It's the same thing, we're just trying to find the roots. And if you were to solve this out, we should get r. You can use factoring like this, or you can use the best method would always be the quadratic formula. So, but we know it's going to be minus 3 minus 3. Because if you do this r squared minus 3r minus 3r minus 6r plus 9. But obviously the best method would always be the quadratic formula, which is negative b plus or minus square root b squared minus 4c over 2. You're gonna wanna, it's good practice to just stick to these. So we got 6 plus or minus square root 6 squared minus 4c, 9 for 4 times 9, whoops, 4 all over 2. So we get 36, this whole thing's 0. And then it's just 6 over 2, which is 3. So this thing's equal to 3. And then once we get that, so we know that the fundamental set, so the actual way to write this would be e raised to the power of RT, comma, and because we have, so if these were two distinctive roots, it'd be e raised to the RT and e raised to the RT. This is if they're two different roots. Since we have two of the same roots, it would be like this. Same thing, now we just put 3 in both our r's. So the answer to this equation would be this. And our general solution, that would be in the form of y is equal to c1 e 3t plus c2t e 3t. That's our general solution. And so let's say you have y double dash minus 6y dash plus 10y is equal to 0. And solve, we got r squared minus 6r plus 10 equal to 0. Probably use the quadratic formula. It's equal to 6 plus minus square root of 6 squared 36 minus 4 times 10, 40 all over 2. 6 over 2 is 3 plus or minus 36 minus 40 is negative 4. Square root of negative 4 is 2i. 2i over 2 is I. That's what r is equal to. So we know that the discriminant is less than 0. Therefore, we'll have two complex conjugate complex conjugate roots, sorry. And in this scenario, we are going to use the general solution of e raised to RT, not raised to r since we don't have any real roots, raised to this t cos e I genuinely can't remember what this symbol is called. I'm gonna go with acceleration because that's what I know from dynamics. So to know what that symbol is equal to, that will be this. So that's what this is equal to. And then the I is what the coefficient of the t in the sign will be. So this is what, let's go for x over here. Will be x in this scenario. And it's 1 because this is 1. It's actually, so in this situation, our general solution will be e3t cos t, e3t sine t. And our general solution will look like this basically. Y is equal to e3t and then parentheses c1 cos t plus c2 sine t. If this ends up being 0, then there won't be any e in your general solution. So, an exam question that usually everyone gets wrong, because no one really shows much importance to it, is finding the minimal order of an equation. So, let's say we're given the solution of a differential equation, just one, and it's t squared e 3t plus t e power of negative t. So that is a solution of a differential equation that's only one solution though, and they ask what is the minimal minimal order of the differential equation. So the way we do that is by finding the fundamental set. So we look at our t's, and there's, if you don't realize the pattern in what I'm doing, because I'm not going to explain it thoroughly, just because you should just know how to do it, because it's a simple pattern. You look at the t's and you look at the separate t's and the t's that are in the exponent of the e's, okay? So let's go with e3 of t first. So that is 1. And then we have e3 of t, t. And then we have t squared, e3 of t. Those come out of this first term entirely. Now we look at this. We have t, we have e to the power of negative t. So we have e to the power of negative t, and then we have t e to the power of negative t. These are a fundamental set of the characteristic equation. And if we were to count the 1, 2, 3, 4, 5, there are 5 of these fundamental roots. Therefore, the minimal order of the differential equation would have to be equal to 5. So the order, I'm going to say order is n, would have to be equal to 5. And you do that by finding the fundamental set of roots. And you do that by looking at whatever solution they give you. Okay, so solving a second order differential equation without constant coefficients. So that'll be done using, there could be a few methods, but if they give you the first solution, which in this case they are, then you can use the method of reduction. The method of reduction does state that y of t is equal to c of t times y1 t. Since we know y1, which is equal to 1 over t, and z is just always going to be z, we know that y of t is equal to z over t. This is just something you'll have to know. Using this, and this is in the question, we have one of the solutions and we have the differential equation. We can find y of t. And using y of t, we can find y dash of t, which will just be the derivative of this. This is also equal to z t negative 1. So y dash would be equal to z dash t negative 1 minus t negative 2z. Using this, we can also find the second derivative, which is equal to z double dash t negative 1 minus t negative 2 z dash minus t negative 2 z dash plus 2t negative 3 z. So once we found this, it's looking already pretty ugly. We know that in this situation that negative, so we know that we can add these two, and then we can also start to substitute in certain equations. So let's get started on that. We have double dash t negative 1 minus 2t negative 2 z dash plus 2t negative 3 z. So we found y right here, y dash and y double dash. So we can plug that in to the actual equation, which is t squared times y double dash plus 3t times z dash t negative 1 minus t negative 2z plus y, which is plus zt negative 1. And this all equates to 0. This is homogeneous, but not all of them are homogeneous. It's just that this question somehow ended up being homogeneous. So once we have that last equation, I'm going to simplify it further by multiplying out the t squared and all that. Z double dash minus 2z dash plus 2t negative 1 z plus 3c dash minus 3t negative 1 z plus t negative 1 z is equal to 0. So let's see, t negative 1 z plus 2t negative 1 z is 3t negative 1 z minus 3t negative 1 z all cancels out. We're left with just tz. Looks like we have plus 3z dash minus 2z dash, which also ends up just being plus z dash. That all is equal to 0. The entire thing simplified out to this. So now we're left with z double dash, this is 2 dashes, and z dash. So what we're gonna want to do is denote the z dash as u, just to get rid of our derivatives there. So once we do that, we know that z double dash will be equal to u dash. And we use this to substitute in u dash plus u is equal to 0. And now what we do is we find our little integrals. So what we can do here is, like I said, u dash is also equal to du over dt. Sometimes writing it out as du over dt ends up making it look easier, because now if we look at this, it does become a separable differential equation. So we can subtract u on both sides, equal to negative. Multiply this out, you can see that it does become a separable differential equation. It ends up being 1 over u du is equal to 1 over t, it's negative, dt. And we can integrate both sides with respect to their own variable. Once we've done that, we find that we're just gonna ln u is equal to negative ln t plus c, and then we find that u is equal to plus or minus e c1 1 over t plus, let's see, and that will be equal to, looks like they're putting c1 t, because that is a minus. Okay. And now, if we recall what z was equal to, we recall that z is equal to the integral of because u is equal to z dash, therefore the integral would be equal to z. So the integral of u, which is now equal to c1 over t dt. This entire thing is equal to c1 ln t, absolute value, plus c2. And now, since we have z, we know our final equation according to reduction rules would be equal to y is equal to y, 1t zt. We can finally plug zt back into our equation. We know y of t, it was already given, it was 1 over t. We know c1 ln t plus c2 is our z, therefore that will end up being a differential equation. You can probably simplify it more, but it doesn't really matter. So now if you have a non-homogeneous equation, which are usually the worst in pre-midterm stuff, but it's also the last thing in pre-midterm stuff. So the way you have to do this is it's non-homogeneous since it's equivalent to something. We have to use the method of undetermined coefficients to figure out this differential equation. So the first thing we have to do is we have to find our we will first find, so this, it's relatively simple for the first half of the question. The first half, you just take this, we convert it into a homogeneous equation, and we just solve for this. And that will be the first part of your answer. So this entire thing, if you put it into the quadratic formula, which would be -1 plus or minus square root of 1 squared minus 8 over 2, you would end up getting a 2 complex conjugate roots, which would be -12 plus or minus square root of 7 over 2i would be equal to r in this scenario. And since that's r, we know that our fundamental set and our general solution will be c1 e to the -12 cos of square root of 7 over 2 x or t, whatever they're using, plus c2 e -12 sine square root of 7 over 2 x. And now we have to add this half of the equation. The way we find this half of the equation is by finding a particular solution to this question, to this part of the equation. And to find a particular solution, we have a formula that you'll probably have to know, and that is this. So e to the power of this times q of x, which is just a function. So we equate these two, we put 2 of x squared, I'm just gonna draw a line right here, 2x squared is equal to e to the power, there's no e in here. If there's no e on the right side, you already know that this is equal to 0t. Because that would be equate the entire thing to 1. And we have q of x or g of x or whatever you want to say. It's just a function. We know the function will be equal to 2x squared. Because this entire thing will be equal to 1, so we know q of x. So therefore we know that this is equal to 0, and our function is equal to 2x squared. So we want to find a polynomial with the degree of 2, and everyone knows the polynomial of degree 2. It's the most basic ax squared plus bx plus c. That is a polynomial of 2. So once we find our polynomial of 2, we have to put it into our characteristic equation after we've found each derivative. So we know that this is equal to y. Alright, it's just a characteristic equation. This is also just equal to y. We know that y, actually, let's not put that there just to not confuse. Y dash is equal to 2a x plus b, and then y double dash is equal to 2a. And our characteristic equation will always be whatever is here, which is, we can use r's, r squared plus r plus 2. So we put each one into these, but we have to put it in matching the characteristic equation's coefficients. Therefore 2a plus 2ax plus b plus, since only the last one has a 2, the rest of them are just 1s, we have to multiply our final by 2ax squared plus bx plus c. This is getting a little confusing, but bear with it. Once you found that, this entire equation is now equal to 2x. Do you understand how we've just substituted in a polynomial of degree 2 into our left side of the equation to get this? And once we've done that, we can substitute in, just gonna erase this. So we can substitute in these values. So we know that because each of these represents, so this represents r squared, this represents r, this represents the 2, and the same thing would go here, except there's just 0x plus 0. So this represents r, this represents r, this represents 2. We match them up. We don't need to use our a's or our x squareds. Well, we need to use our a. We don't need to use our x's, because x's are variables. A's are not. They represent constants. They don't represent variables in this situation, which is why you have to use them. So 2a is equal to 2, a is equal to 1, 2a, which is 1, plus b is equal to 0. Therefore, b is equal to -1. Then we have 2ax squared. Why don't we just plug it in? Plus 2 -1. I don't know why I'm putting x's. I just said don't put variables. Plus 2c is equal to 0 again, which means c is equal to -1/2. Sorry for being such a shitty prof right now, because Just woke up. So using this, we found A, B, and C. We plug that back into our characteristic equation. If you recall, ax squared is bx plus c. It will be equal to x squared minus x minus half. And we add that on to the solution of this homogeneous equation.